Hello, good afternoon. My name is Miguel Salazar from Group 108, Team 1, and in this video we are going to present the experimental process that my team and I carry out to demonstrate that it is possible to produce biodiesel from microalgae oil. Our main objective was to obtain ethyl biodiesel, also known as FAID, from microalgae lipids using 86% ethanol as a solvent and reagent and sodium hydroxide as a catalyst.
Hello, I am Andrea Garcia and I explain the part A of this experiment, lipid extraction with 96% ethanol. To carry out the experiment, we used the following materials and equipment: chlorella powder, 96% ethanol, which serves as both an extraction solvent and reaction alcohol, 1% sodium hydroxide, which acts as catalyst, Baker's separation funnel and filter paper, analytical balance, graduate paper, and thermometer. And finally, glass jars with aerating lids, an amber bottle to store the final product. Next, place the biomass in a 3 glass jars with an air lid at 300 milliliters for each one of 96% ethanol and shake for 60 minutes at a temperature between 25 and 35 degrees Celsius. This condition allows the ethanol to dissolve the natural oils in the microalgae. After the first extraction, we let the mixture soak, filter it, and save the first extract. We repeat the process with 200 milliliters of new ethanol to perform a second extraction with the residue from the previous extraction. Then, we combine both extraction and remove the solvent using a water bath at temperature less than or equal to 45 degrees Celsius until we obtain an oily residue. We wait till the oil obtained to calculate the percent of lipids. Explanation of reaction conditions. In the first part, the reaction condition refers to the physical and chemical parameters that we control to ensure that the process occurs properly. Temperature of 25 or 35 degrees Celsius. Time of 50 or 60 minutes per extraction. Biomass solvent ratio 1 to 10. Solvent 96% ethanol. Drying method, water bath. Although this stage does not involve a chemical reaction as such, it does require constant conditions to achieve maximum lipid extraction.
The part B of this experiment consists on ethyl transesterifications with sodium hydroxide. In the second part, we transform the oil into ethyl biodiesel. First, we dry the oil by heating it to 105 degrees Celsius for 10 minutes to remove any traces of water. Then, we prepare a catalytic solution by dissolving sodium hydroxide, 1% of the oil's weight, in the corresponding volume of ethanol, following an ethanol oil molar ratio of 9 to 1. Next, we place the oil in a beaker with magnetic styrene head heated to 60 degrees Celsius and add the catalyst solution. The mixture is kept between 60 and 90 minutes under constant stirring. Finally, we transfer the mixture to a separating funnel and let it rest for about an hour. Two phases formed: a light yellow upper phase, biodiesel, and a denser darker lower phase, glycerol. We drained the glycerol and dried the biodiesel in a water bath at less than 60 degrees Celsius until it was completely clear and free of turbidity. We transferred the biodiesel to a secure amber bottle. Explanation of reaction mechanisms. In this part, a chemical reaction known as transesterification does occur. Here, the triglycerides in the oil react with ethanol in the presence of the basic catalyst sodium hydroxide, producing ethyl esters, biodiesel, and glycerol as a byproduct. Sodium hydroxide reacts with ethanol to form sodium ethoxide, a strong base. This ethoxide attacks the carbon in the carbonyl group of the triglycerides. The ester bond breaks, releasing a glycerol molecule and forming a new ethyl ester. This process is repeated 3 times, generating 3 molecules of biodiesel for each triglyceride. The expected yield of the process was 10 to 20% of lipids extracted from the biomass, and 85 to 99% conversion of those lipids into biodiesel. This demonstrates that chlorella prototychoides is an excellent source of raw material for obtaining sustainable biofuels.
In conclusion, this experiment demonstrates that it is possible to produce biodiesel from microalgae efficiently and sustainably, using ethanol and sodium hydroxide, which are easy to obtain and less pollution than the materials used in traditional methods with methanol. This type of process could be implemented on large scale in the future, offering an environmental-friendly alternative to fossil fuels and contributing to the reduction of environmental pollution.